variable width or pulse width modulation through the control wire. So there is a minimum pulse, a maximum pulse, and a repetition rate. A servo motor can usually only turn 90° in either direction for a total of 180° movement. Okay, 180° movement. Okay, this is a set of degrees. We can change the degrees based on that. Arduino gives the pulse and it will change the action. Okay, it's a variable width of pulse. Next thing is a current sensor. It's a current sensor working as a ACS 712 Hall effect current sensor. You can see this animation here, the Arduino board and one stepper motor and a 7-segment LED display. So here ACS 712 is a Hall effect current sensor. So that Hall effect will convert the magnetic field created by the current. So that is a sensor to voltage directly proportional to and make this sensor able to generate voltage linear. And it will measures the current, how much it will flow through the circuit. So the current sensor working. Next, we are using the another one controller is Raspberry Pi. So Raspberry Pi is a series of small single board computers. So it is used to learn programming skills, build hardware projects, do home automation. So that Raspberry Pi hardware module, this is the hardware module. So mainly Raspberry Pi to learn programming skills, build hardware projects. And the minimum requirement is a Raspberry Pi 2 model B device. There is a Raspberry Pi 3 model B, 8GB class, 4 SD cards, and a USB micro power supply. The mainly features of Raspberry Pi is the high-speed 64-bit quad-core processor with the clock speed up to 1 GHz. So dual display support resolutions up to 4K via a pair of micro HDMI ports. There is hardware video decode at up to 4 kilobytes, up to 4 gigabytes of RAM, dual band, the wireless LAN. So these are the main features of the Raspberry Pi. So in that IoT applications where we are using the home lighting, wireless technology, smartphones, home and application, personal computer, analytics, flight services, online shopping, music, and all. Here we can see the block diagram for the sensors and the signal conditioning circuit. So in that, Atmega microcontroller is there, auxiliary power supply, and the ESP32 Wi-Fi. That is the ESP names expressive systems. That is the short name ESP. Expressive systems that provide that mainly provides for Wi-Fi connection and dual mode Bluetooth connectivity for embedded devices. So ESP32 is technically so it's just this chip. It's just a chip and modules and the development of boards that contain this chip are often to refer to as ESP32. Okay, this is a Wi-Fi technology. That is nothing but expressive systems. So based on this, we can make that IoT-based smart energy meters. So you can see this in animation. A smart energy meter using IoT. It's a potential transform way to consume and track energy. Outflow, whatever, like that. By providing real-time monitoring and control of energy consumption, it can help to reduce their energy usage and automatically we can save money and promote sustainable energy consumption. So this is the main IoT-based energy monitoring system. So applications of IoT-based energy monitoring, it's a unit consumed, how much unit consumed, and transmit the units as well as a cost charged over the internet using Wi-Fi connection. So this allows user to easily check the energy usage along with the cost charged online using a simple web application. So mainly consumption and transmit the units. This is the IoT smart energy meter. So we may take the readings in our smartphones itself. Next part is IoT based water level control. How we can monitoring like that. So in that, IoT water level is a monitoring system is a smart automated solution. So various applications we may use as tanks and reservoirs, swimming pools, that and all that with the IoT devices, sensors, and the cloud-based platforms, and collect, process, analyze data. That water levels we can use to optimize water usage and prevent wastage. That and all we may use in the IoT-based water level controller. So here we can use the ESP 8266 model also, and waterproof ultrasonic sensors and measure water levels, and the screen display LED displays are there, and the water levels for easy monitoring. Okay, so these are the automatic water level detection. Using sensors, we can detect the water level, and it will automatically fill by using this control pump. Okay, and water level goes down, it will make a audible alarm also, and the high also it will indicate. Okay, next we may link for electric vehicle. First, what is an electric vehicle? So electric vehicle is defined as the vehicle that can be powered on an electric motor that draws electricity from a battery and is capable of being charged from an external source. So this is the parts of an electric vehicle. So electric vehicle is nothing but an electric motor and inverters and drivetrain, batteries, and charging. Okay. So these are the hybrid electric vehicle. So what is in the hybrid? Hybrid means it will be powered by an internal combustion engine. IC engine also be there, and one or more electric motors. More electric motors also be, which uses the energy storage for batteries, because that is purpose of motor for energy storage of batteries. The hybrid electric vehicle, so it cannot be plugged into the charge of the battery. Instead of battery, charged through a regenerative breaker. That is the main thing, by a internal combustion engine. How it will work? So here fuel as a primary power source and do not require external electrical source for recharge the batteries. But in internal combustion engine and the electric motor work together to propel the vehicle. So these combination to increase the efficiency of the engine, increase the efficiency and power distribution allows vehicle to achieve optimum power under most of the driving conditions. Okay, so what are the various types of electric motors used in the electric vehicles? Because in the hybrid, you can produce lower carbon emissions. That is the main thing. It will produce a lower carbon emissions. It's a eco-friendly with the electric motor assisting the IC engine, and fuel consumption reduces. It consumes less oil compared to their conventional counterparts, and it requires lower maintenance than conventional cars. Okay, so these are the main features of the hybrid vehicles. So we may see what are the motors we can use. So DC series motor, brushless DC motor, and permanent magnet, and three-phase induction motor. So these are the motors we are using for the hybrid electric vehicles. So DC series motor, we should know, is a high starting torque. So DC traction purpose, cranes, because of the high starting torque, DC speed control. So here connection is the armature and field windings connected in the series, a DC source. So motor speed varies, non-linear function, load torque, armature current, and stator yield current. Okay, so this is the DC series motor and brushless DC motor. The special electrical machines, brushless DC motor, electric motors that do not require the consumable brushes and commutator. Mainly do not require a brushes and commutator, and low maintenance also. That brushes is a commutator driving a brushless DC motor done electronically in the driver set. Okay, so overall, speed and torque produce less noise in a traditional brushed motors, less noise and more efficient. Now the fans and all is coming BLDC motors because of high efficiency. That is the brushless DC motor. That's the thing, permanent magnet synchronous motors. The permanent magnet synchronous motor uses permanent magnets embedded in the rotor to create a constant magnetic field. Okay, so the stator carries windings, electrical supply, and the rotor is a rotating magnetic field. That is synchronous motor. It's nothing but a synchronous motor. Next, three-phase induction motor. Should know that electromechanical energy conversion device which converts three-phase input electrical power into mechanical power. Okay, so how in that applications of IoT used in the electric vehicle? Yes. Mainly, we may use a monitor charger availability. Okay, charger availability and provide data. And this IoT for EV monitoring and management system. That is battery management is a main research is going on this. So that is BMS, charging and discharging cycle of the battery. Okay, that is the main thing and ensures battery health and also minimizes the risk of damage by confirming that enhanced energy. So mainly IoT in the battery management system, you can see. So the benefits of IoT in monitoring and management is first IoT in the battery management system. Second one is IoT in safe and smart driving. So safe and the smart driving, we can monitor the real-time data, the vehicles and their key components. So is making user more reliable. So IoT devices embedded in electric vehicles can provide users for this safe and smart driving because it will help to monitor the driver performance. Mainly, it will monitor the performance and key parameters like speed of the vehicle, acceleration, and temperature, and it provides real-time tips to ensure better performance. And we can prevent the theft of the vehicles through real-time tracking, geofencing, immobilization, that and all. We can use the theft of the vehicle also. The complete EV and battery manufacturing companies can improve their products. So in the theft proofing, your current prices of electric vehicle, you should know more expensive than the normal petrol diesel engines. So two-wheelers also more expensive. This is on to theft. The cost of the battery is expensive and IoT could help to more effective tracking. It's a mainly tracking mechanism. Okay. Because the cost of the battery alone, 40% of the total cost of the EV. So we can protect from theft. So also used for non-demand apps, food delivery, cargo delivery, bike sharing, hyperlocal delivery, that and all. IoT can use the track down real-time location of EVs in case any stolen. Okay, so IoT can raise the alarm and notify the owner about the theft. That is the main thing. Next, fall down crash detection. Most IoT devices built in the accelerometers. So they can monitor the acceleration and the angle of the vehicle. Mainly, the sudden change in the acceleration angle of the vehicle can be detected easily by IoT. And it notifies the owner about the fall down or crash. It will notify. And this can also be very useful to inform about severe accidents. This and all immediately it will inform the owners. Okay. So IoT plays a vital role for that fall down and the crash detection. And ease of leasing batteries. The performance and the location of tracking of batteries. That is one of the most important features of battery swapping leasing components. And to track or monitor the batteries, IoT major role because the theft of the loss of battery is a major thing. So we can easily leasing the batteries. And the fault alert and the predictive maintenance. So in the high-tech machine, we can experience technical faults that IoT fault alert systems. So in that alerts vehicle drivers regarding the faults and gives them enough time to act as to address. Okay, by using this IoT, the charge cycle of the vehicle, kilometers travel, and so on. That is the battery temperature, and we can use this data for regular maintenance, the tires, lubrication cycle, battery life. So monitoring the other wear and tear parts of the vehicle. So it will replace on the time. On time replacement is a mandatory, and it could be help to damage of the vehicle. Also helps to increase in the life of the vehicle also, the battery's life. Okay, so this is the main fault alert and the predictive maintenance system. So these are the benefits of IoT in monitoring management in the vehicles. Next is some disadvantages also be there. And first one is risk of cyber attack. So because completely we may using this through internet. So use of high amount of data sent over a network makes this data more cyber attacks and data theft. The hackers may access the system and steal the person's information and misused. Okay, so that risk is available. And high cost of electric vehicles. So that IoT system used in the electric vehicle are quite advanced and high installation of running cost. Okay, so it makes overall EV more expensive. So in the near future, there is a possibility to reduce the overall cost by doing more R&D in that area. They are doing so many research in that area to reduce the cost. Okay. Next, technical complexity. Here, by designing, developing, maintaining, and enabling the extensive technology, it's quite complicated. That's the overall design. Okay, this technical complexity. And EVs become more complex, and it is not easy to handle. Okay, so designing, developing a maintenance scheme, it's not easy to handle. And connectivity, power dependence. So here EVs have a dependency of internet and continuous power to function and provide real-time data properly when either goes down. So does the device and anything connected, it will also be go down. So it will affect the overall performance of the vehicle. So connectivity is a main important thing. So these 4 parameters we can take apart for research. And another one thing, IoT applications in autonomous electric. So it's a recent research article from Arabian Journal of Science and Engineering. Mainly connected and autonomous electric, CAEV. It's connected and autonomous electric vehicle will evolve ways that will have a major impact on transportation infrastructure, major impact on the automotive industries, as well as vehicle ownership. So the number of connected vehicle continues to grow. So conventional vehicle that adopt networks are now evolving the Internet of Vehicle, that is IOV, that is Internet of Vehicles. This plays a vital role. So IOV may be referred as a platform that enables the exchange of information between the vehicle and its surroundings through various communication media. So in case of connected autonomous vehicle, it may be referred to Internet of CAV, conventional vehicle, and this CAV toward an automated driving and the test beds of CAV, including automated charging management services for taxi services, So these are the mainly deals about that autonomous electric vehicle system. Next thing, another one research, wireless charging systems. It's mainly charging point. It's a wireless charging system. It's a transformer working principle. That wireless charging, there are transmitter, receiver at 220 volt, 50 hertz AC supply converted into high frequency alternating current. And this is high frequency AC is supplied to the transmitter coil. It creates alternating magnetic field. We create the alternating magnetic field that cuts the receiver coil and causes the production of AC power. So this is the main principle output in the receiver coil. So important thing that is efficient wireless charging is to maintain the resonance frequency between the transmitter and the receiver. And to maintain the resonant frequencies, compensation networks are added at both sides. So that finally AC power receiver side rectified to DC and fed to the battery through a battery management system. Yeah, battery management. This is a complete wireless. So in the block diagram, 220 volt 50 hertz AC supply converted into high frequency alternating coil for high frequency AC to transmitter coil and creates alternating magnetic field that cuts the receiver coil and causes the production of AC power output in the receiver coil. So mainly resonance frequency between transmitter and receiver. To maintain the resonance frequency, compensation network are added for both sides. That is compensation added. So mainly AC power receiver is converted into DC because of the charging of the battery. This battery management system, we can charge. Okay, so this is the wireless charging system basic principle. And IoT based smart EV charging station. And in that charging, there are two principles are there. One is static, another one is dynamic wireless charging. So based on this static wireless charging, dynamic. So in the same principle, we can. So what is the static means? The vehicle gets charged when it remains static. It remains static. So here we could simply park the electrical vehicle at the parking spot or in a garage, which is incorporated with the wireless charge. So here static, while vehicle in a static place, it will charge. And the transmitter is fitted, ground and receiver is arranged in the vehicles under. So the charge vehicle align the transmitter and the receiver. So the charging time depends on the AC supply. Mainly depends on the AC supply, distance between the transmitter, receiver, and the pad sizes. So these are the static. Another one is dynamic wireless charging system. It's dynamic means name indicates vehicle gets charged while in motion. While moving itself, will charge. The power transfer over the air from stationary transmitter to the receiver coil in a moving vehicle. By using this dynamic vehicle that's charging system, traveling range should be improved with the continuous charge. This battery while driving on roadways and highways. Okay, so it reduces the need for large energy storage, which further reduces the weight of the vehicle. It will further reduce the weight of the. Okay, so there is two types of charging methods. One is a static wireless charge. Another one is a dynamic wireless charge. Okay, so static is nothing but vehicle gets charged, remains in a static place. And the dynamic, it's charged while it is in the motion. Mainly what's current research in the EV charging? Wireless charging by magnetic induction. So this is the research is going on. The vehicle charging can be done through either houses itself, through available AC supply, or through fast charging via charging stations. So unavailability of charging station in all locations and sudden reduction of battery conditions makes the critical situation to the electric vehicle. So wireless induction charging is electric current and magnetic field and generates electric current in a second coil at some distance. Okay, so this is the electromagnetic induction principle, which will soft iron core, primary winding. It's a transformer principle, it will induce us the voltage. So these objectives of the current research on EV charging, it will that platform observing the electric vehicle battery conditions and facilitates the easy charging methodology. Mainly this objective, and to develop the system which provides an effective charging method, and to integrate the charging demand vehicle and charging supply vehicles instantly, and to improve the communications between vehicles and enhance the integrity. So mainly these are the objectives. And current research is the vehicle to be charged and the vehicle to be supplied with charging to the damaged there's a demanded vehicle, and charge controller battery unit is a main part, and transceiver sliding mechanism, induction charging cabin, and the IoT. So this is charge controller. The EV charge controller plays a vital role for charging process. It controls charging process that can be charged efficiently. So this is the fuzzy control for standalone EV charging station. So based on that, we can use the MPPT technology, can use the PWM techniques, pulse width modulation techniques to boost converter, and then a charge controller, one direction DC to DC converter, bidirectional DC to DC converter, and the fuzzy BAD controller can charge the batteries as well as the one direction DC to DC converter will charge direct to the vehicle. That is the main mechanism of the fuzzy control. So this fuzzy controller helps that that CPV scheduling algorithm determines the proper pair of the charging station. Proper pair of the charging station. So that applications we may use that fuzzy logic controller, autonomous vehicle systems. That is fuzzy set theory to help us to make decision to various areas such as vehicle management. So the mainly EV charging station we can use the fuzzy control. And then sliding mechanism, it's operated through a spiral spring adjustable mechanism for the smooth movement, and the sliding mechanism gives the end and flow movement, charging port and EC for from nearby vehicle. So mainly IoT role, it's a integrate the two vehicles, that is charging required vehicle and charging supply vehicles through data and control process. So the data on batteries conditions initially stored in the internal unit. So once the battery charging condition gets low and its data transmitted to the cloud, now the process of searching the nearby vehicles is started. So battery data is maybe nearby vehicles received by the cloud. Okay, this is the role, the direct requisition to send nearby vehicles which have the sufficient battery storage, and the acceptance of the vehicle through the vehicle driver. This is the main thing. The data on the battery data is verified with charging processes initiated. Okay, these are the references. So this is my overall presentation. So in that scene, how IoT applications. Then a quick summary how IoT applications, but mainly what are the terms in the IoT? Main thing, sensor, actuators, and controllers. Okay, sensor, actuators, and controllers. So different types of sensors we may see. So ultrasonic, gas, color, PAR, accelerometer, potentiometer, IR sensor, this and all. And then we've seen that some animations also in accelerometer, PAR sensors, and the range sensors, and the color sensors, and the potentiometer, the variable resistance method, and the thermistor module. So these are the sensor. And the actuators, what are the actuators we seen? Discussed hydraulic actuator, pneumatic, and the electrical actuators. The electrical actuators. And servo actuator. So this is the sensor to actuator. This is the difference. And the Arduino controllers, using this servo motor controller. Current sensor with the Arduino controller. And the Raspberry Pi. So these are the controllers. So sensors, different types of sensors, and actuators, and the controllers. So next thing where we are using applications, like the smart energy we can see. Smart energy meter and water level indicator. And it will connect to the electrical vehicle. Okay, we can see the hybrid electrical vehicle, what are the motors we may used, and what is the applications of IoT in the electrical vehicles. So this is the main thing. IoT in battery management system, safe, smart, theft, fall down, and easy for leasing batteries, and the fault, alert, and the predictive maintenance system. This is the main thing. Some demerits also we see, and the autonomous electrical vehicle, and the wireless charging systems. Wireless charging systems. Okay. And IoT-based smart EV charging stations. The main research in the wireless charging stations is in okay. And fuzzy method also we see. Okay, so these are the references. So any questions regarding this?
Participants, if you are having any questions, you can ask now.
So this is the complete IoT applications in the electrical vehicle. And monitoring and measurement of complete electric vehicle.
Sir, I think there is no questions. Thank you for your speech, sir.
Okay, sir. Okay.
Participants, we are posting the feedback link for day 3. So kindly fill the feedback. The feedback link will be available for 5 more minutes. Kindly fill the feedback.
Barnabas sir.
சார் சொல்லுங்க சார்.
சார் அவங்க சார் லீவ் பண்ணிடலாமா அவங்க சொல்லுங்க.
சார் ஒரு photo எடுத்துருவோம் சார்.
போட்டோ எடுக்கணும். சரி.
So participants, can you turn on your video? சார் அந்த ஸ்க்ரீன் ஷேரிங் கொஞ்சம் நிறுத்தினா தான் வீடியோ. சுந்தரராஜன் சார். ஓகே.
ஸ்க்ரீன் ஷேர் ஆஃப் பண்ணிட்டேன் சார்.
Okay. Participants, kindly turn on your videos. We will take one screenshot.
Ramesh Babu sir, so we can take another 5 minutes for interaction session.
If the participants are willing, then you can proceed, sir. No problem, sir.
Okay, interaction session. So what are the sensors we can see? We can see in the sensors. So participants, you can type the.
Participant, you can type the questions, whatever if you record.
What are the sensors we see? You just participants requested to chat, because so this is for summary. This is for a revision for that today's class. So what are the sensors we see? Just type it. What are the sensors we discussed today? I think this typed messages will display it. It will display, sir?
No, sir. No, sir.
Okay. So what are the sensors? So accelerometer sensor, PIR sensors we see, no? So just type it. So rain sensors, very good. Rain sensors. And another one sensor. Temperature sensor, very good. Then another one, it will display, and what is color identifier? Very good. So color sensors. So these are the sensors seen today discussed. And actuators. What are the types of actuators we discussed today? Types of actuators. Actuators, anyone? Servo motors. Okay, servo motors. Servo actuators, actually. Yeah, servo actuators. Next. Another one, it will works in the oil, no? Oil, air. It's a so it's nothing but mechanical actuator. So what is the name? Hydraulic. Hydraulic actuator is a mechanical actuator, and pneumatic. Hydraulic and pneumatic. Could you please type this one? Hydraulic, pneumatic. And mainly electrical actuators. So these are the actuators we discussed: hydraulic, pneumatic, and electrical actuators. And last one is servo actuators. And what are the controllers we discussed today? Controllers. Pneumatic, hydraulic. Okay, fine. Thank you, madam. Next, what are the controllers? Controllers. That is IoT mainly 3: sensors, actuators, and controllers. So what are the controllers we discussed today? That is one small board and one larger amount of board. Small board. Arduino board. You see, no? Arduino board. And another one board name. Raspberry Pi. Its question is there no? What
Question
about
is, what about Hall sensor used inside the motors to identify the position, sir? Silver sir is asking.
okay. That's your questions. Hall sensor. I'm not. Please tell the question, sir.
Sir, what about Hall sensor used inside the motor to identify position?
Inside the motor.
Inside the motor, it will be available inside the motor or not? He's asking first question.
Oh, Hall sensor used in the motor, no? BLDC motor we may using.
Yes,
Okay.
sir. Yes.
So what types of Hall sensors? So mainly we can use this that is Hall sensor we are using that is provide information for location. For location we are using the Hall sensor. So which type of Hall sensor? No, your question. Which type of Hall sensor?
Sir, actually, sir is asking whether Hall sensor inside the motor or outside the motor. He's asking.
It's provide information to location of the rotor, sir. So inside the motor only.
Okay, right. That's a question.
Inside. So that is meant by latching Hall effect sensors.
Okay.
It's mounted in the motor, sir.
Right, sir. Right, sir.
So that is the purpose of position of the motor.
Yes,
The
yes.
position and the electronic controller. That is that all. So it will read. So it will mounted in the motor itself. Name of the Hall sensor is latching Hall effect sensors.
Okay, sir. And next question, sir. Kokila ma'am is asking, how to generate gate pulses for converter using Raspberry Pi? From Raspberry Pi controller we are using, no? How to generate?
Yes, sir. Yes, sir. How to generate
gate pulses
gate pulses
for converter using Raspberry Pi controller.
Using Raspberry Pi. Okay. So how to generate gate pulses using Raspberry Pi? That is, I think, gate pulses using Raspberry Pi to generate PWM pulses.
Yes, sir. That is only
That is
question.
PWM pulses. That is so it's a function of Arduino function. Arduino function. This function we can include some extra models. So that's PWM clock device. We can include. We can include the PWM. But Raspberry Pi generate the PWM pulses. That is, that the hardware board supports software pulse width modulation. That is, it will supports only software pulse width modulation, PWM. That is, pins are there. Each pin outputs square waveform with the variable frequency and duty cycle. That is the main thing. I think that PWM output frequency is 10 Hz. It's Raspberry Pi hardware board supports only software pulse width modulation.
Software pulse width.
Software pulse width.
Yes.
That is the main.
Next question, sir. Lognathan sir is asking, which kind of sensor used to monitor battery charging?
Sensor monitor the
battery charging.
Battery charging monitoring sensor. Battery monitoring means that is we have to see the battery health, that is health condition, aging and state of charge, that and all. I think this is a mechatronic device. It's a battery sensor is there, sir. But it is a mechatronic device, sir. That is future sensor models, integration of electronics and integrated battery reduction. It's a mechatronic device, sir. It's a mechatronic device. That is current sensor, voltage sensor, and temperature sensor. These three sensors will monitor the battery sensing and monitoring system. Battery sensing and monitoring system. Current, voltage, and temperatures. Three sensors.
Okay, sir.
Current, voltage, and temperature sensors. Because we can see the battery health, battery charge, and battery health, the state of health, that is aging. That is the main thing. And mechatronic device also be there, and three sensors: current, voltage, as well as temperature sensors.
Participants, any other questions?
Sir, shall we end, Ramesh Babu, sir?
Yes, sir. We can conclude the today's session.
Okay.
Okay, sir. Okay.
Thank you.
Thank you, sir. Thank you.
Okay, sir. Thank you very much.
Thank you.
Thank you very much for providing this opportunity. Thanks, sir.
Thanks, sir. Okay, bye, sir.
Sir, Sundarajan, sir, can you end the meeting?
Okay, sir.
Okay.
Sir, feedback.
Link போட்டாச்சு link 2 தடவை
Okay, sir. We can stop the end the meeting.